Anyways, I can just not.
Yeah.
I don't have any.
Is there anyone that has any questions at all on your homework that you want me to go over? Anything at all? The ones that I've graded so far, and so this is due, oh gosh, this is due tomorrow. So homework 5, homework 6 is due tomorrow. We're going to cover homework 6 today, and it won't take you very long to get them done. So I want to make sure that you have it down pat, because we're going to move on. The ones that I graded, there's some of them when you're doing the miles per hour to meters per second, you really have to have that separation where you change miles to meters first, and then you're going to change meters to hours, or however, hours to seconds in the second phase. So it's going to be a long unit multiplier. There's going to be, 3, 4, 5 different unit multipliers that you're going to use. Do not get in the habit of using, especially, and you should keep practicing, don't get in the habit of using the internet to change it or come up with your own unit multipliers, because on the test, all you're going to have is that reference sheet. That's it. So you only get what's on the reference sheet. So make sure you know how to use that reference sheet very well. So any questions at all? We answered yours. You guys good? We answered yours. Delaney, you're good? Okay, anybody on Zoom have any questions that you want me to go over for the homework?
No questions.
Good. Okay, all right, well, here we go. Okay, so what we're going to do is we're going to switch gears, and we are going into order of operations. So this is considered, how you guys signed up for your, you signed up for 13, 14 college algebra, and then you also signed up for 0214. So this is that part of it. This is the correct part. It's a way to support you throughout the class to make sure you have all the right, turn the lights on, all the right tools you need to complete and college level portion. So what we're going to do today is we're going to talk about order of operation and then linear equations, how to solve linear equations. And we're going to focus very deeply on how to get rid of, how to eliminate fractions, because that's going to be super helpful. Okay, so the first thing that you need to know about is absolute value. So absolute value has these vertical bars. And the idea behind it is when you have a number line, and we go negatives on the other side, absolute value means the number of steps from 0. Okay, so it's a distance. So what that means is it's always going to be a positive value. When it comes out of those absolute value bars, it's going to be a positive value. So in other words, if I said, I want the absolute value of 1, it's a 1, of 1. Well, there's 1 step away from 0. Makes sense, right? If I wanted the absolute value of -1, it's also 1 step away from 0. So it's a positive 1. So absolute value, because it's a distance, will be a positive value. Now, where it gets confusing is, what if I said I want the absolute value of 2, over, of 2, so the absolute value of 2 is 2, but if I put a negative sign in front of that absolute value sign, what this means is I want the opposite of 2, the opposite of the absolute value of 2. So the opposite of the absolute value of 2 is -2. So be careful, because when I say absolute value is always positive, that is a true statement. But if there's a negative sitting in front of it, then it changes the sign, because it's asking for the opposite of it. So if I had the opposite of the absolute value of -2? Well, absolute value of -2 is 2, but I want the opposite of that, so it's -2. Okay, does that make sense? All right, so absolute value are 2 vertical lines. So you're going to look for that. Whenever you're doing order of operations, and I don't know if they come up on anybody else's feed, but I always get these order of operation questions, and which one, what's the right answer? And you get a million different answers. Well, the reason that you get a million different answers is because in math, you have to have a certain sequence. You have to have it in a certain specific sequence. If you alter that sequence at all, it's going to mess up your answers. And that's another reason why calculators, people, when they rely on their calculator, they don't enter the right symbols, like parentheses, at the right place. And so it throws it off. So you have to make sure that your order of operations is in the right order. The other thing that I found, and I actually had a student argue with me one time, that you're always going to do multiplying before division. And the reason he says that is because everybody knows this one, right? PEMDAS. Right? And the way it's written, it does show multiplying before division. So let's just make sure we are all on the same page. P stands for parentheses. I like to call it G for anything grouping. So parentheses, everyone knows what that is. But in order of operation, you may have brackets, you may have a brace, or you can have parentheses. So any of those are considered a parenthesis. All it is it's an organizational tool. It keeps things organized for you. So P is parentheses. Sometimes I will call it G. Does anyone know what E stands for? Good. So exponents comes next. So just a reminder, if you have 3 squared, that's the same as 3 times 3, which is 9. I cannot tell you how many times I get 3 squared is 6 and 2 cubed is 6. So 2 cubed is 2 times 2 times 2, which is 8. Okay, so that's an example of exponents. So it's whatever the base is, you multiply it however many exponent it says. So if there's exponent is 2, you're going to multiply that base twice. If the exponent is 3, you're going to multiply that base 3 times. Okay? You're not multiplying those 2 values. So exponents, another way to see that is repeated multiplication. That's what an exponent is. It's a repeated multiplication. Okay, so we're good here. We have the grouping terms, we have the exponents, we're good to go. The M and the D are what? Good, so M is multiplication. D is division. Here's where it gets confusing. You do your multiplying and dividing in order from left to right. Okay, so just like you're reading a book, right? You're taking it in order from left to right. So if you see division first, you're going to do the division first. If you see multiplication first, you're going to do multiplication first. So the way I like to write it is M over D. So it is a choice. It's not one before the other. It's whatever you see first as you're reading left to right. Okay, and then the last 2, A and S. Everyone knows those? Good. So addition and subtraction. And again, you do these 2 in order from left to right. Just like you're reading it. When you're reading a book, you don't read right to left. You always read left to right. Okay, so I use addition and subtraction, again, they're lined up, which means I have a choice. If division comes first, I'm going to do division first. If subtraction comes first, I'm going to do subtraction first. If you stick with this order, you will never get these wrong. But you have to be diligent about sticking with the order. Okay? All right. So what I did, because there's never enough room on these packets, is I went ahead and recreated the first 12 problems. So this is on page, it's on page 249 in your packet. So if you want to use your packet to do these. And like I said, the way that they're laid out, it's going to be very hard to get all the work in. So you might want to do this on a separate piece of paper, just as we work through them. Okay, so here we go. We have our grouping, we have our exponents, we have our multiplying, dividing, and we have our adding and subtracting. And again, these two are in order from left to right. That's your order of operations. All right, so on number one, and I'm going to try and highlight these. Here's our first step, right? Because it's in those grouping symbols, it's in parentheses. So on all of these, what you're going to do, I want you to think of it like a funnel, right? We're going to start with something big and we're going to funnel everything down to where we end up with one answer. Okay, there's our funnel. So you're going to break it down, break it down, break it down. And I want you to take it step by step. I don't want you to bounce around, and I definitely don't want you to use your calculators. No calculators on this. All right? Okay, so 10 minus 2 is 8. And notice what I'm doing. I'm just writing backwards. I'm taking one step, and then I'm writing backwards. Now, as you get better and better and better at this, you can kind of start combining steps. But for now, I want you to take it one step at a time. All right, so now you look across and you go, okay, I have subtraction, I have addition, and what is this? What's this 72 and 8 showing? Multiplication, so I'm gonna do that next. So 72 times 8. 8 times 7 is 56, plus 1 is 57. And then again, I'm writing backwards. So I'm starting in the grouping, and then I'm doing multiplication. That's my next step. So I'm even right here. So I did grouping, then I did multiplication. Now I have only subtraction and addition. Okay, so as I'm reading left to right, I'm going to do subtraction first. So 5 minus 3 is 2. And now I'm down to one answer. 2 plus 576 is 578. And that is my one answer. Now, obviously, these are we're gonna, look at number 2. We've already started building, right? So we're gonna continue to just kind of walk through the process. So these are these grouping symbols. So what I don't like about all these parentheses is it can get confusing, right? So what I like about the grouping symbols is I can make this into a bracket, and it still represents the parenthesis, but it just gives me more organization. So I go, okay, so here's a bracket. That's a grouping symbol. Within that grouping symbol, I have grouping symbols again. So I'm going to do inside the inside parentheses first. So 1 minus 4 is -3. And again, I'm just going to keep writing. And we're taking something big and we're just sifting it down till we have one answer. And don't forget your exponent on the answer. All right, now what's next? Mm-hmm. Okay, so remember, it's grouping symbols. So we already got rid of the grouping symbols on the inside, and then it's exponents. So inside the bracket, we're going to do the exponents. So -3 squared is 9. Okay. So we have grouping, we have exponents. And then we're going to do it again. So we're just going to focus on this one set of parentheses or brackets. So 1 plus 9 is 10. So 10. And we still have the squared. And again, as we get better and better at this, we can combine some of the steps. All right, so now we have grouping here. So we're still doing grouping. We have grouping right here. So let's go ahead and get that one. So 3 minus 6 is a -3. And what I'm doing is I'm making sure that I'm not missing anything, right? This 2 keeps coming down, this 2 keeps coming down, the parentheses keep coming down, and now I've simplified the parentheses. This big bracket came all the way down and sifted till we have 10 squared. Okay? All right, what's next? The what? Good, the exponent, right? So 10 squared. So we're going to go 100. Oh, that's okay, you're here. Glad you're here. All right, what's next? Then you're going to jump in the middle. So you can see it's completely okay to jump around. You have to focus in on the correct order. So 2 times -3 is -6. And now we have all the same. Adding and subtracting, working left to right. So 2 minus 6 is a -4 minus 100. So we end up with -1. Okay, so all of that gets sifted down to one answer. Okay. All right. Any questions on either of those two? And really force yourself to take one step with every line. And before you know it, you're going to be getting these correct over and over and over again. Now we're going to have plenty of practice today, and then I'm going to send you off. I think 4 problems that I'm going to have you do on your own. Make sure that you all get the same answers, and then we'll move on. All right, so here we go. So this square root, this is a square root sign. So the square root means what times what gives me whatever's underneath. So the square root is considered a grouping symbol. Okay, so we can't do anything the way it sits, so we have to simplify first. So simplify under radical. That's another term for a square root, is a radical. So read it. Okay, so we have the square root sign. 5 squared is 25. 3 squared is 9. So again, keep simplifying. What's 25 minus 9? 16, good. Okay, now you ask yourself, we're simplified, we've got the square root sign. Now you ask yourself, what times what gives me 16? 4 times 4. So the root, excuse me, the root is 4. But what about -4? If I do -4 squared, what does that equal? equals positive 16. So anytime you have a square root, you're going to have two answers. You're going to have the positive version and you're going to have the negative version. Because 4 times 4 is 16, so 4 is a root. Negative 4 times negative 4 is also 16. So negative 4 is also a root. So there's two answers. Now, real quick, and this is a super common error. If you had this and you had this one here, the second one, we know because it's -3 times -3, right? That's what it's saying. -3 times -3, which is a positive 9. But on this one, you only have one negative. So what this is saying is 3 squared is 9, but then I want the opposite of that. So it's a -9. So these are two completely different answers. And this is why when using a calculator, people get them wrong all the time. Because if they're entering -3 squared on your calculator, it's reading it as the opposite of 3 squared, as opposed to parentheses -3 and then parentheses squared. So be real careful when you're doing negatives, especially with an even exponent. You have to know, is there parentheses? Am I using that negative or am I not? So the idea is this one, I have one negative. But this one, I have two negatives. So one negative is a negative answer. Two negatives is a positive answer. So it's all based on how many negatives you're using. And that way you don't have to, go negative times a negative times a negative times a negative. Okay? So that's just something on the side that I want you to be aware of. So, room. All right, so now we have absolute value bars. Okay, so absolute value bars are also a type of grouping. These are also grouping symbols. So that's why I like the grouping instead of parentheses, because it allows you to have different symbols. All right, so inside the grouping symbol, the absolute value sign, we have 4 minus 8, which is -4. This little dot also means multiply. It's another way to show multiplication. So there's parentheses, there's a number with parentheses, there's a dot. So it just depends on how it's written. But these all show multiplication. All right, so absolute value of -4. What would that be? So how many steps away from 0 is that? Good, it's 4. Okay, and then 9 times, and then inside the parentheses. So now we're going to jump over here and do 2 minus 3, which is -1. Okay, and again, all I'm doing is once I get an answer, I just rewrite the rest of the problem. So be real careful that you don't miss something. All right, now this is multiplication. So -9 times -1. Positive 9, good. And then we have addition. So there's your answer. So absolute value bars, you can just use them as, oops, what I wanted to do. As grouping symbols. Because once you get here, this was a positive 9, and then it's 4 plus 9. Instead of 4 times 9, it's 4 plus 9. because this becomes a positive 9. Okay. The question was for Zoom people, the question was, how did I know to add? So that's where that came from. Okay, so what I don't want you to do is I don't want you to look at all of these different order of operation type problems and go, every one of them is different. The order of operations is the same, no matter how it's set up. The order of operations is going to stay the same. It just depends on if you're using, fractions or fractions within fractions. It's all part of the process. So whenever you're doing ones like this, where you have a top and a bottom, so this is the numerator, just to give your numerator. This is just your terminology. This is the denominator. So what I like to do with these is I work out the numerator first and get an answer. So I'm going to come here and just kind of work this one out first and get an answer. So 7 times 7 times 7. So 7 times 7 is 49 times 7. Is 343 plus 8. So what is that? 351? Yeah, 351. Okay, so that's my top answer. Then I'm going to get the bottom answer. So 17 minus 3 is 14. And then I look at this, and this is how I decide whether I can reduce this or not. Because top heavy is good. I'm good with top heavy, right? As long as it's simplified to the lowest term. So the factors of 14. So factors of 14. This is just how I go through. Factors of 14 is 2 times 7 or 1 times 14, right? Well, 2 can't go into 351 because it's an odd number. 7 goes into 35, but it doesn't go into 10 evenly, okay, or 1 evenly. So I know 7 won't go into that evenly. So this is my answer. I'm gonna stick with it. Now I'm curious to see how they write it in the back. Hang on, let me check the answer in the back. Just because I don't want to give you false hope. Okay, so in the back of the book, if you looked at, they changed it to 25 and 1/14. That's a great answer. 351 over 14 is a great answer. So if that ever happens, where you have a top heavy answer and they give you in the back of the book, they give you a mixed number, just go ahead and double check that your mixed number fits or is the same as, is the same as the 25 and 1/14. And that I will count it as correct. If it's on the test or the quiz or the homework that you turn in, I would use that. Give you credit for that. Okay, everyone good on this one? Do the top, do the bottom, and then combine the two. Yeah, go ahead, Yahira.
I had a question for when we do 7 to the power of 3.
I can barely hear you.
I'm sorry, hold on. Do you hear me better now? Hello?
No, can't hear you at all. Can you type it in the chat? your mic isn't working. Okay, I'll wait for your question. Okay, so number six again, don't let it freak you out. Just go, okay, I got this. I'm gonna break it up into parts, right? So I'm gonna work this one out because we love fractions. We all know how to do fractions, so we're just gonna get the answer at the top. So 2/5 plus 1/3. So this is where all the information that you guys got at the beginning on fractions, you have to remember how to do. So what's our common denominator? Okay, good. So this one I multiplied by 3, so I get 6. This one I multiplied by 5, so I get 5. So this is 11/15. So just this part is 11/15. And then what's 2 cubed? So 8, okay, 8, good. Okay, so this one, how did we combine it? Because, oh, I see what you're asking here. So you here is asking, why did we, it's a good question. For this part right here on number 5, the 2 times 4, why did we do +8 instead of +2 and then that answer times 4? Can anyone give a answer to that? Why did we multiply first before adding? Yeah, it's the order of operation. So with order of operations, you're always going to do multiplying first. You never add if there's something to be multiplied. You always multiply before you add. Okay? All right. So on number 6, this one, we're just going to hang out with it because, again, this is a great example. We never add before we multiply or divide. Adding, subtracting is always the very last thing we do. So this 11/15, 11/15 over 8, what does this line mean right here? Division. So you can actually write this as 11/15 divided by 8. So now how do you divide fractions? 11/15 times, you flip it and multiply. Flip and multiply. So it's going to be 11/120. So now we have 1 plus 11/120. Okay, so how are we going to add this? You know what the easy way is? Whole number plus a fraction is a whole number and a fraction. That's it. If this was a 3, it could be 3 and 11/120. If this was a 10, it could be 10 and 11/20. So as long as we're adding, we can just put the fractions together. A whole number and a fraction is literally a whole number plus a fraction. Okay. Now, we have 6 more and then we're going to move on. All right, so here's what we're going to do. For those of you who are on Zoom, do number 7. Get the answer, put it in chat. For you guys in here, do number 7, and then let me know what your answer is. And we're going to see how many different answers we get. Hopefully we get however many people there are. The same answer. That would be, that's the goal. I'm so proud of you guys. Do you know we have had 2 weeks straight, 100% attendance. That's awesome. When we came back from COVID, it was terrible. We had so many absences. So hopefully it's getting better. All right, Emma says a negative 108. Anyone have a different answer? I'm gonna write all the different answers over on the side. We got another one? Yes. Okay. That's what you got too, Kaylee? Delaney? Okay. Should we just say, majority rules? Emily, what'd you get? Same thing? All right. Okay. Okay, so here we go. So inside parentheses, we have 6. Okay. So this is a great example. This -3, there's nothing in between the -3 and the parentheses, so it's showing multiplication. So then we're going to do exponents. And then 36 times -3, 18, 108. So -108. Perfect. Good. Okay. So for those of you on Zoom, don't ignore the process. I wanna see your answers. Thank you, Emma. Yeah. You can do it either way. I could have done it this way. Because this is just one value, it can go either way. So it doesn't change how it works. If that was a negative, you would be right. Yeah, but because 6 is positive, then I can put it either way. But yeah. Okay, number 8, go for it. So be careful reading it left to right. Division, multiplication, multiplication, division. And there's, how many people are there? There's 10 people in Zoom. So I want 10 answers in the chat. Thank you, Daniel. We'll have to see. I hope you're not wrong too. Okay, there's one answer, but don't just say it, that's your answer because it's written there. I want you to own your work. Be confident in the process. Do you have an answer, Haley? Okay, that's okay. Let's write it. You got 21? Okay, that's all right. I think doing it this way is a great way to see, okay, why are we getting different answers? Annalie, what'd you get? 29? Okay. Okay. Okay, don't give up. Just give me an answer. Okay, so go back and recheck your numbers and come up with a value. Own it. You got this. You got 21? And don't just say I got 21 because the majority rules. Okay, Jalen got 21. We got a couple 21s here. You got 18. Okay. You know what? You might be the only one right. You never know. Okay, we got another 21. Okay, here we go. What are we going to do first? Okay, Nathan got a 29. All right, what are we going to do first? Good. So there's no parentheses, there's no grouping symbols. So then we jump to exponents. Let's write this here. You guys have this down pat, right? So we're going to start here. So 4 squared is 16. I'm just going to keep writing. Now, does this make sense? Because this is -4 squared. So it's not parentheses. So there's only one negative there. So that makes that whole thing negative. All right, what do we do next? Okay, because we're looking at this left to right, the only thing left is adding, subtracting, multiplying, dividing. So we're looking left to right and we see the division first. So what's 48 divided by 3? 16, good. Jade says she got -3. Thank you, Nathan. He says it's okay. He got -3 the first time too. All right, so as we're going through this, look at your work and see if it's tracking. Where are you off already, or where did you go off, or are you good so far? Okay, so now what do we do? Then you're going to do multiplication. Good. So 16 times 2 is 32. Okay, now it's all adding and subtracting. So if you notice, I haven't done any adding or subtracting. The only thing I've done is exponents, division, and then multiplying. And then the very last step is the adding and subtracting. So 32 minus 16 is 16. 16 plus 5 is 21. All right, so if you did not get 21, just backtrack. Where did you go wrong? And then let me know. Okay, so Yuritsa says she multiplied before dividing. Anybody else get it wrong the first time through? Okay, so the -4 squared thing threw Jonathan off. No, so what this is saying is, this is, if you look at just this part, it's 4 times 4. Okay, this negative says I want the opposite of that. So it's kind of like -1 times 4 times 4. That's what that's saying, because there's only one negative. So an odd number of negatives, your answer is negative. If you have an even number of negatives, your answer is positive. And that's true. Yeah, that's another way to see it. So Kaylee says she thought it was 4 squared, which is 16, and then you just drop this negative sign. That works too. But technically, it's the opposite. So Daniel says he did the division first, then multiplied, but I did it wrong somewhere. Okay, so look and see where you so Jade, I don't know if you were here at the beginning, but whenever you're doing order of operations, see how I write PEMDAS? Multiplying and dividing and adding and subtracting are stacked. So it's always, as you read it, left to right. So because we read left to right, it was 48 divided by 3 first. That's what you do first. And that's why people get them wrong all the time, because they remember PEMDAS and they think multiply before division, but it's actually as you read it left to right. All right, here we go. Number 9. Let's give it a shot. Let's see if we can get all the same answer. So this is with the stacked or a fraction type. So do everything in the top, get an answer, and then do the bottom. Okay, that is 7. You get anything different? $11, okay. Okay, so which is what? -7, huh? And that's what you got, Jonathan? Okay. What'd you get, Dylan? -7, okay. -7, okay. Okay, we got another 7. We got another -7, okay. Oh, of course, yeah. Just make sure that little black thing is pushed into the door so it doesn't lock. Yeah, if you push in, yeah, There we go. All right, here we go. So I'm going to work the top first. So here's another technique that you can do if you have enough room. I just work up. So I'm going to do inside parentheses. So I'm going to do multiplication first. So I have 6 here. That's inside parentheses. And then over here, notice the dot. Hopefully you caught that. So this is 3 times a -1. I don't like how this looks, but we're just going to go with it, is -3. Okay, then I'm going to come back to the beginning. 4 plus 6 is 10. 10 plus a -3. So I have a 7 on the top. Okay, and then down here, that goes back to there's only one negative. So it's over -1 because 1 squared is 1. And then I want the opposite of it. So it is -7. Good. So if you got +7 or 11, go back and see, okay, where did I get it wrong? So this right here, this part right here catches a lot of people. Just remember, there's only one negative there. So it's 1 squared is 1, but it wants the opposite of it. As opposed to that. This means -1 times -1. There's 2 negatives there, which makes it a +1. Okay, and that's the difference between the two. Okay. Yes. Well, and you can also look at it as that exponent is only sitting on the value. It's not sitting on the negative. That's 2 completely separate things. So, good. Okay, next one. Go ahead and try number 10. And then let me know when you have an answer. What is it? 7/16? 15/8. Okay. Okay, people aren't as confident in your answers on this one. 7/16. Okay. I saw that look. What was your answer? Uh-oh. Kaylee, did you get an answer yet? Not yet? Okay. All right, Zoom people, give me an answer. What did you get? All right. Oh, sorry, Kaylee. I was asking the Kaylee in class what they got for this new one for number 10. Okay, so we'll go ahead and get going here. So we need a common denominator. So again, it doesn't have to be the lowest, and in this case, it is the lowest. So I just multiplied 5 and 3. This one I have to multiply by 3, so I get 9. This one I have to multiply by 5, so I get 5. So 9 plus 5 is 14/15. So that's the top. And then on the bottom, 2 cubed is 8. So this is 14/15 divided by 8/1, which is the same as 14/15 times 1/8. Then I can cross cancel, right? 2 goes into 8 4 times. And 2 goes into 14 7 times. So I end up with 7/60. Did you say 60 or 16? 60? Oh, okay. Sorry. I wrote it wrong. There it is. So if you didn't get that, go back and look, see what you're doing. So remember, whenever you have this big division sign right here, this just means divided by. So you're going to flip that bottom one over and multiply. What'd you do? Gotcha. Okay. Okay. So the reason why I want you guys to figure out what you're doing wrong is because that's how you learn, right? You go, oh, I added instead of multiplied, or I didn't flip it, or whatever it is, or I didn't use the right symbol, sign. So that way you always have something in your mind of, okay, this is what I want to look for. I want to make sure that I'm doing it correctly. And what was the mistake that I made last time? I'm going to learn from that and move on. Otherwise, if you don't identify the mistakes, then you just keep doing the same thing. You just keep making those same mistakes. So that's why I'm not trying to like call you out and go, no, you did it wrong. I just want you to identify what you're doing. All right, 2 more, and then we're going to move on to linear equations. So 11 and 12. Oh, nice, Emma. Trust the process. Okay, we got a 4. Emma, you're fast at these. Did you get the answer yet? That's okay. Tell me what you got.
26.
26. Okay. Did you already look to see what the answer is? Okay. All right. So, okay. So look and see as you're waiting, look and see, okay, did I do parentheses first? Do I have the right sign? Right?
I think that's right.
Mhm. Yeah. So like on this part right here, just this one, what'd you get? Yeah, okay, so that's right. And then you have to do, then you add to that because it's inside the brackets or inside the parentheses. And you got 2, Yuritsa, you said? Okay. 12, okay. What'd you get? 4, okay. And Jonathan, that's what you got too? Okay. All right, Zoom people, I'm not seeing any answers. You have to engage. The only way to get good at math is actually do it. I can't believe we're finishing week 3. That's crazy. Oh, I know. Oh, I can't even think about it till 2 weeks before. I'm that person. Do you really?
It's easier, like I'll do like one kid each week, and then I just alternate this week. I'll get my daughter's thing next week.
Okay,
The week after that one set.
okay, that's a good way to go. Okay, so we got another 4. Okay, here we go. So inside parentheses, and you can do either one, it doesn't matter. Inside parentheses, if you always want to make yourself, oh my gosh, why is this so angled? If you always want to make yourself writing or reading it left to right, that also works. So just left to right. So 4 plus a -6 is -2. Okay, and then inside these parentheses, -2. So again, this is in parentheses, so you're using that negative twice. So you have 2 negatives, which makes it a +4. So this is 1 plus 4. So we have 5. So I'm going to rewrite this because it's a little messy. 3 plus 2 times -2 plus 5. Okay. Now what? Yep. So 2 times -2 is -4. And now you have all adding and subtracting. So working left to right, 3 minus 4 is -1 plus 5 So your answer is. Okay, so again, go back and look and see, okay, did I miss the negative? Did I not use that negative twice and got -4? There's always a reason why it doesn't come out correctly. Okay, what was it?
So, I was going, so I did the, like, everything that was in the that
This side? Oh, the other side. Okay. So, okay, so what you did is you added before you used the exponent. Okay, so it's always exponents first.
Oh,
Even if it's in the
Oh,
parentheses,
okay.
yeah. So even within parentheses, you always do the same order of operation as you do exponents, multiply, divide, and so on. Okay. Where did we get 5? Oh, you hear the 5 came from this -2 squared is 4. Oops. So this is 4 plus 1. That's where the 5 came from. Okay, so the squared is only on the -2. So even within parentheses, you always do order of operations within parentheses. All right, last one, and then we'll move to linear equations. So number 12. And those are absolute value bars. I feel like we've gotten worse instead of better. We started out with 1 or 2 answers. Now we have 4 or 5 answers. So really pay attention. That exponent 2 is on the whole set of parentheses. So work within the parenthesis first and then apply the exponent. Do you have an answer, Kaylee? -27? Okay, Emma got the same. So far, so good. Now everyone's going to work towards negative. Okay. Good, Kaylee. What'd you get, Jonathan? Got -27. Yay, we broke the chain. And I don't know if it helps to show you things that I've seen that people make mistakes on. because I don't want to confuse you. But so I'm going to do this in red. So this is what you don't do, because I have seen this a ton. So a lot of people will take this 2 and they will distribute it to both terms. So the reason why you can't do that is because this is squaring the whole thing. It's not squaring individual pieces. So if you did it this way, you'd end up with 1 plus 16, which is 17, much different than the 25 that you're supposed to have. So whenever there's terms inside parentheses, go ahead and get that first and then apply the exponent. Okay, because you are doing order of operation, you're doing parentheses first, you're simplifying within parentheses, and then you're doing the exponent. Okay, all right, so negative 27 is the answer. We got 5 squared. We have 4 minus the absolute value of negative 5 is 5. So 4 minus 5, that's where that came from. And then 4 minus 5 is negative 1. And then 2 times negative 1 is negative 2. And then negative 2 minus 25 is negative 27. Okay, so this absolute value of negative 5 is 5, but then this negative sign gets brought down. Okay, everyone good? All right, so what we're going to do, so that's order of operations. Now what we're going to do is we're going to talk about linear equations. And this whole lesson probably could have been separated out, so I hope it doesn't overwhelm you too much. Order of operations is something that is going to come back often. So we'll hit it, and then we'll hit it again, and then we'll hit it again. So the way that I like to introduce linear equations is we always want to talk about what are we doing. So whenever we have equations, there's 2 different things that we are looking at. We have an expression, and then we have an equation. And they're 2 completely different things. So an expression is like 2x plus 3. You cannot solve it. There's nothing you can do to do anything else to it. You can't combine like terms. You can't add it. You have no idea what the x is. That's an expression. An equation is when you have an equal sign. Now you can solve. Okay, now you have a means to solve it because you have a way to figure out what x is. So like order of operations, what we're doing is we are untangling and we're working in the opposite direction to get x all by itself. That's what it means to solve for x. So solving for x means isolate the x or the variable, whatever the variable is. You're isolating it. You're getting it. It's tangled up in this function or this equation. You're untangling it by doing the opposite. Okay, so we have to establish what are opposites. So what is opposite? Here we go. What's the opposite of addition? Subtraction. Okay, so if you have something like x plus 3 equals 5, you can logically think through, okay, so what do I add the 3 to get 5, right? Because this equal sign, remember the old fun days of elementary school when you had a teeter-totter? You guys probably don't ever remember a teeter-totter, do you? Oh, that is so sad. Do you had a teeter-totter? Gotcha. Have you ever been up to the Ridge? They have an adult teeter-totter. It's awesome. It's like this huge wooden plank, and yeah, it's awesome. So a teeter-totter is like there's a balance fulcrum, right? You have to keep it balanced. So the idea is if I take 3 away from one side, I have to take 3 away from the other. Otherwise, it's no longer balanced. So whatever you do to one side, you got to do to the other. So what happens is when you add and subtract the same value, that becomes 0. So it cancels it out. So I have the x is isolated on one side. 5 minus 3 is 2. Now, how do you check? Well, you can do this. You guys will get really quick with this. You just plug it back in. What's 2 plus 3? Does that equal 5? If it does, then you've got the right answer. So there's always a way to check it. Now, if you start with, I didn't see these chats here. Oh, very good, Caleb. So if you start with subtraction, move this down. If you start with subtraction, then again, we want to isolate that x. So how do you get rid of a -3 or a -3? You add 3, good. Again, this cancels to 0. So I have x equals 8. Check. 8 minus 3, does that equal 5? Yes, it does. So I know I did it correct. Okay, so these are called one-step equations. Because all you have to do is take one step. You add or subtract depending on what you're given. You always do the opposite. All right. The other one-step equation is if you have, I'm going to do it with a dot. What's the opposite of multiplication? Division. Okay. So that's a one-step equation. So if I had 3 times something equals 15, this is showing multiplication. So to isolate, I'm going to divide both sides. So 3 divided by 3 is 1. 1 times x is x. So I've isolated my x. And then 15 divided by 3 is 5. And then again. And this check, you can do it mentally. I'm just writing it down so you can see how I'm mentally checking. So 3 times 5 does equal 15. I'm good to go. Okay, so that's when it shows multiplication. Now, where people get really confused is if they have one like this. So something divided by 2 is going to give me 10. So it's still a one-step equation. This is showing division. So to get rid of division, I'm going to multiply both sides by 2. What that does is it cancels it. Okay, so it's the exact same idea. Here it showed multiplication, so I divided. Here is showing division, so I'm going to multiply. So my x equals 20. So to check, 20 divided by 2 does equal 10. And it checks. And that's the only value it can be. That's why equations are so important, because it's giving me that exact value. That's the only value that x can be in those instances. Okay. All right, now we're going to do two-step. Classic Texas two-step. Great way to have fun. All right, here we go. I'm keeping the numbers small just so that they're easier to work with, but the process is the same. Now, with order of operation, do you remember we do multiplying, dividing before adding and subtracting? Now, because we're untangling that x, we're going to get rid of the adding and subtracting first. So I'm subtracting 3 from both sides. That cancels it. I end up with 2x equals 2. So this is my first step. And then my second step, I'm back to my one-step equation. It's showing multiplication. I'm going to divide. And then I can check it. Same idea. 2 times 1 plus 3. Does that equal 5? Yes, it does. So I'm good. Okay, so once you, this right here is your answer. That's the answer. This is just a check. Is my answer correct? That's all that is. All right, and again, you can do this mentally. I can plug this one in here. 2 times 1 is 2. 2 plus 3 does equal 5. I'm good to go. Okay, what about this one? So again, we're untangling that x. So get rid of the plus or minus first. So I'm going to add 7 to both sides. That cancels. And now I am back to a one-step equation. Okay, so this is x divided by 5, so I'm going to multiply by 5, which cancels that. So my x equals 75. Is that right? 15. Yeah. Okay, so to check it, 75 divided by 5 is 15. 15 minus 8, oh, sorry, minus 7 does give me 8, so I check. Right? So that's one step, 2 steps. So here's the good news. Every equation that you solve is going to go back to the 2-step equation, which is going to take you back to the 1-step. So this is your goal. You got to get to a 2-step equation. That's going to be your goal, and you're going to get really good at this. Okay, so let me show you. Now what we're doing is we're gonna add some layers. So this is multiple steps. But remember, it's all to go back to your 2-step equation to solve. That's the goal. You want to take it back to that 2-step equation to solve. All right, so here we go. 2 times x minus 3 equals -5 times x plus 1. Okay, so now we have multiple steps. All right, but again, the goal is get it back to where you have 2 steps. All right, so what does this 2 with parenthesis x minus 3, what does that tell you to do? Yeah, do you remember which property? I'm going to multiply the 2 by the x and the 2 by the -3 because it's 2 times that whole thing. So 2 times x is 2x. 2 times -3 is -6. And then I'm going to do the same thing over here. -5 times 1 and -5. I'm sorry, -5 times x and -5 times 1. Right? So again, the goal is to have a 2-step equation. So if you notice, you have x's and values on either side of the equal sign. So we're just going to move it across. So if I want to move this whole thing, I'm going to add the opposite. I'm not dividing. I'm adding because I'm moving this whole thing over to that side. So I end up with 7x minus 6 equals -5. And now you're at a 2-step equation. Now you know exactly what to do. Get rid of the -6 first, and then divide by 7. So add 6. 7x equals 1, because that cancels, and then divide by 7. So x equals 1/7. Okay, now you can, to check it, you can plug it back into the original. But if I trust my work, I could plug it back into right here. And I get 7 times 1/7, which equals 1, right? Because the 7's cancel. 1 minus 6 does give me -5, so it does check. Or you can take it all the way back if you want, but I trust my work here. And I knew that those were going to cancel, so I'm good to go. Okay. Any questions on this one? Fractions are fine. Fractions are great answers. They're just little baby answers. All right, so I rewrote it because I wanted you to see it a different way. So some people see this 2x and go, oh, I'm going to bring this over here. Is there anything wrong with that? The what? Okay, it gives me a -7, which I'm okay with. But if you notice, I have my 7x on the left. This is my -7x on the right. It's still a two-step equation, right? I'm still going to add before I divide. But then which one am I going to divide by? The 7 or the 1? Right. And why is that? Why do I want to divide by this -7? Yeah, because I want the x by itself. So notice I'm not dividing by x, I'm dividing by the number in front of the x. And so -1 over -7, x equals 1/7. I get the exact same answer. It just depends on how you want to move across the equal sign, right? I have always just moved my x's to the left because then I know I'm going to have that two-step equation, okay? All right, so that's the basics. This is what I was a little bit worried about, is they go right to, let me make these bigger. So this is page 249. This is at the bottom of the order of operations page, and then it goes to 250. Okay, so let me just so I have more room. And you can see they get bigger and bigger, but the process is the same. You're going to take everything over to where you have a two-step equation. And these, I'm going to show you a really sweet way to get rid of the fractions. And it'll make you much happier. I can move these all around. All right. Okay, so number 16, you guys have all the tools you'll need. So go ahead and try it. So use distributive property first. Move that 5 through the x and the 2 and the -2. And then you're back to a multi-step, like what we just did. One of the best second grade teachers I've ever seen. She was fantastic. And she and I taught at the same school, and she would always come to me and go, Ellen, when they started putting letters in there with numbers, I was done. So don't forget, a letter is just a number in disguise. You just don't know what it is yet, but you will. All right, so we distributed. We get 5 times x is 5x. 5 times -2 is -10. And then we're going to move the whole thing over, the 4x over by subtracting. And I end up with 5x minus 4x is 1x. And you can either write the 1 in front or not, doesn't matter. Usually you won't see a 1 in front, so you have to remember there's a 1. And then I'm going to add 10 to both sides, so I get x equals 0. And then to check it, if I always want to make sure that I have it right, I have 5 times 0 minus 2, so 5 times negative is 2. 4 times 0 is 0, minus 10 is negative 10, so we have negative 10 equals negative 10. It checks. Okay, and again, you can do this mentally. All right, any questions? All right, try number 18. And you can see we just keep adding layers to it. But your goal is to get it back to your two-step equation. Your hands tired yet? Are they cramped yet? You guys have been doing a lot of problems today. That's good. You're going to be so ready for your homework to be done. I think there's only, how many questions are there? There's 10 questions. I think 5 order of operations and 5 linear equations. So not too bad. Okay, so for this one, this is the first time you've seen this, where you have like terms on the same side of the equal sign. So we have 10x and a negative x on the left, and we have 7x and 6x on the right. So all that means is you're adding like terms. Did we go over that already? What a like term is? Okay, so a like term means that the variable and the exponent is the same. So it's just I have 10 of these things called x minus 1 of these things called x, so I have 9x. So I have 10 minus 1, I have 9 of them. And then on the other side, I have 7 of these things called x plus 6 of these things called x, so I have 13x. So all you're doing is you're just adding the coefficient, the number in front. So the variables have to be the same. The exponents have to be the same. If I had x cubed and x squared, these are not the same. So the exponents have to be identical in order for it to be a like term. So now you're right back to it, the multi-step one. So 10x minus 1x is 9x. And then 7 and 6 x's is 13. And then I'm going to move the 13 over. And again, if you decide to move the 9 over, that's fine. We'll get the same answer. And then divide by -4. So my x is going to equal -3 halves, because I'm dividing both top and bottom by 2. All right, everyone good? Okay, so for this, for this one, we're doing, it starts with a fraction, and we don't want to deal with fractions, right? We want to get rid of them. So what you're gonna do is you're gonna multiply, and we did cover this at the very beginning. So we're eliminating the fraction by multiplying everything through by a common denominator. Okay, so if I multiply everything through the top by 2, what happens is if I go 2 times 3 and then t minus 7 over 2, and then 2 times t minus 6, okay, so I'm just multiplying everything through by 2, you can see that the 2 cancels, right? So that's one way to show it, or I can show it here. Once I multiply through by 2, this is a divided by 2 times 2, they cancel. Since the t minus 6 doesn't have a denominator, I have to keep that the 2 times the whole thing. And notice I put my t minus 6 in parentheses. So now I end up with 3 times t minus 7 equals 2 times t minus 6. And now you're right back to a pen that you just learned how to do, or you just did. So I just eliminate. I multiply through the common denominator and it eliminates the fraction. Do you have a question? Okay. You look like you were disgusted. So because I have this divided by 2, right? That the opposite of dividing by 2 is multiplying by 2, right? So when I multiply by 2, that cancels the denominator. But whatever I do to one side, I have to do to the other. So that's why I multiplied this side by 2. Okay. And then you're distributing. Move my 2t over. So 3t minus 2t is just 1. And then I'm going to add 21 to both sides. And then again, if I want to check it, it's 3 times 9 minus 7 divided by 2 equals 9 minus 6. So let's see, 9 minus 7 is 6, or I'm sorry, it's 2. This is 2. 3 times 2 is 6. Divided by 2 is 3. And 9 minus 6 is also 3. So I'm good to go. All right, last one. So again, we don't want to deal with fractions. You could deal with fractions if you want, right? The problem is when you end up with a fraction like that, x over 1/3, then it becomes an issue. So I just like every time I see a fraction, I just go through and go, you know what? I don't want to deal with the fraction. I want to get rid of the fraction. So I'm going to multiply everything through by 7. Okay, so I end up with 7 times 6 is 42 over 7. 7 times x is 7x. And 7 times 13 is 91 over 7. And then I reduce. 6 plus 7x equals 13. That's one way to do it, multiplying everything through by the 7 and then reducing. Or I can go through, do it in a different color. I can go through, multiply everything through by 7, and I can cancel it right here. 7 goes into 7 once. This I need to multiply by 7. 7 goes into 7 one time. So I guess 6 plus 7x equals 13. So I get the exact same thing, whether I reduce first and then multiply, or multiply and then reduce. Either way works. All right, so this one, does this one look different to you? Or can we solve it the way it sits? What would you get rid of first? Yeah, so we're going to subtract 6. And then divide by 7. And the more you do these, the faster you're going to get. Because you're going to start seeing, oh, it's a pattern. I'm doing the exact same thing. I'm distributing, I'm moving the x over, and then I'm doing a two-step equation. Distributing, move the x over, and then doing a two-step equation. Okay? I think that was it. Let me double check. Yeah. Yep, you're good. Because we did the fraction lines. Okay, so your homework. So remember there's some different dates. So homework 5 and 6 are due tomorrow. Quiz 3 is due Monday, and that's on Canvas. Quiz 4 is due Wednesday, and that's on Canvas. And then this is what's crazy. We have 3 more topics. Graphing, which is my favorite. I love graphing. Graphing, and then we have our first test. September 26th is our first test. Okay. So always go back in your packet and practice. You should still be practicing all those previous assignments. Yep. 1 through 9. Homeworks 1 through 9 is what the test will be on. Okay. No questions. We're good. All right. Have a great weekend. Stay safe. I feel like I need a weekend at home just to recover. Look, I have to show you how close he was. And that is not.
Wow. That's so nice. How much for y'all's tickets?
They were like
floor, right?
Yeah. Yeah, we were above the
And
floor.
that's the frost thing?
Uh-huh. Yeah,
Oh,
AT&T.
okay.
It's awesome. Have you been to the rodeo there?
No.
Okay.
I haven't. Yeah, we only moved here a lot.
Oh, okay. The rodeo's cool. They do the rodeo. It's like 2-3 weeks, and then you pay a ticket. It's for the rodeo, and then there's always a band after. So like Keith Urban's going to be there. Brooks and Dunn's going to be there.
When is that?
February. It's in February. Yeah, they're just putting the lineup up, and the nosebleed seats are still really good because we're up there. If you're afraid of heights, it's not. No, and you can get tickets for $30 each up in the nosebleed
That's
seats.
nice. So
Yeah.
we went to Wyoming, the Frontier Days, Wyoming.
Yeah.
So it's kind of pretty sad. That was my
Yeah.
kid's first concert. Was part of my home and he runs it. And my daughter, and my son, the one who's autistic, I thought